All right, this is a fifth video that I'm making. My original four were from a previous semester, and they've changed a little bit of five of the questions types that we had before. So I just wanted to make a little bit of an update to that video and go through those specific ones. So this is just one version of the practice test. Obviously, yours might be different because they jumble the numbers and questions every time you open it. But looking at number 12, this is one that was not on my previous set of videos. So it's find the vertex and axis of symmetry of the quadratic function, determine whether the graph is concave up or concave down, graph the quadratic function. So the first thing we want to do is determine the vertex, and we are luckily in what we call the vertex form. So this is a parentheses x minus h squared plus k, where the vertex is going to directly relate to this h and k. It's opposite to what we see inside, so that's going to be +1 and exactly what we see on the outside, and so +2. So h and k, where we write the opposite sign of whatever we see for h. The axis of symmetry is directly related to the x-coordinate of the vertex. It's a vertical line that splits the parabola in half. This graph has a negative in front, so that means it's going to be concave down. If we have, that means the bowl looks like it's flipped upside down. If we have a positive in front of this vertex form, then we're going to have concave up. Then we want to and do the graph. So we open up the tool. Let me clear some of the other writing. Or actually, let me just see if I can move it off to the side. There we go. So we're going to pick the parabola tool, and we're going to go to our vertex, which is 1, 2. I'm going to go ahead and click that. And then we want to pick a second point, but we don't know one yet. So I would then go over to the side and work out another point. Usually if my vertex doesn't include 0, I would use that. So I'm going to do g of 0. That would be -0 minus 1 squared plus 2. So that's going to be -1 squared plus 2. Be careful of this. That does not multiply. You square this first. You bring your negative down from the outside. So this is going to be the point 0, 1. Okay. So we'll plot that over here. Turn my mouse back on. So 0, 1, and save that. So let's go ahead and type in everything we need for that, just so you can see the formatting. Do an ordered pair because it says that there. Type an equation means x equals 1, and the graph is concave down. Okay, so that's what everything should look like on that one. My next one, I'm going to go ahead and clear the drawing, is the one right after that, number 13. It's exactly the same type, so let's see if we can do this one quicker. The vertex here would be opposite of what we see inside, so that's a 1, comma, and then the outside is also a 1. So this time our ordered pair is 1, 1. That means my axis of symmetry is x equals 1. Again, I have a negative in front, so I'm going to be concave down. I'm going to need to show some work to get the second point because we know our vertex. So if I plug in 0 again, because my vertex doesn't have 0 for x, that's -0 minus 1 squared plus 1. That's -1 squared plus 1. That's going to be 1, but we have the negative in front, so it ends up being 0. So this is the ordered pair 0, 0. So when we go to graph, you always plot using your tool for parabola. You plot your vertex first, which was 1, 1. Then you plot your second point, which ended up being 0, 0 this time. Okay, so that takes care of the plotting quadratics or parabolas, talking about concave up, concave down, vertex, and using the tool. So the next one on my list that was not on my previous set of videos was number 15. We had similar things on the previous versions of this exam, but they were matching questions and they weren't really good. So I'm kind of glad that they've changed them to these. This is a natural log function. I prefer, just me, to write it more like a transformation. So I'm going to write f of x equals natural log of x because that's our parent function, and then bring the -6 to the end. I didn't change anything except the order of the terms. So I can definitely see that this is going to be shifting down 6. We know our transformations because this is the parent function right here, natural log of x, and this is what's happening after that. Your domain, when you're dealing with natural log, has to do with inside or log either. It has to do with what's inside this argument. So whatever's inside that argument, we set that greater than 0 and solve it. Well, it's already solved. So this would just be, and they want interval notation, 0, comma, infinity. And we do not put a bracket here because in natural log or log, we don't want to be equal to 0 because that does not work. If you try typing in natural log of 0 on your calculator, you're going to get an error. So our domain is always whatever's inside the argument needs to stay greater than 0. And we solve that to get the domain. The correct graph. So that means that we have a vertical asymptote at x equals 0, since that's where our domain starts. Normally, your natural log would be a point. So I'm going to write what natural log looks like without the shifting down. You have your asymptote at x equals 0. And we have the x-intercept 1, 0. And this is just a rough sketch. And then the graph kind of goes like this. Okay, that's the shape of it. I could get a lot more points, but this is not really giving you a lot of detail. We're just looking for the right points. So this set of choices here, we don't want this one because that's beyond our x equals 0. This one's also shifted to the right too far. It should be closer to the x equals 0. So it's either A or B. This one looks like they shifted up 6. This one looks like they shifted down 6. So since we have down 6, we're going to go with A. The range of a logarithm function is always all real numbers. Okay, so that is negative infinity to infinity. And then we have another part. So let me scroll down. The vertical asymptote we already said is x equals 0, so we can write that in. Now they want us to find the inverse. Okay, so finding an inverse, I'm going to rewrite my function as y equals. When you do this, we swap x and y. This is one method, the algebraic method. And we try to resolve for the y. So I'm going to add the 6 over. And unfortunately, now my y is stuck inside that natural log. So remember, natural log has a base of e hidden here. To convert this to exponential form, which is what the inverse of logarithms is, we do base to the answer on the other side, that's our exponent, equals the argument. So e to the x plus 6 equals y. So since y is f inverse, we're going to just write e to the x plus 6. Now it's then going to ask you about the domain and range of this function. Well, the domain is going to be the opposite. Remember for if you know your inverse is the x and y's are just swapped. So our domain used to be 0 to infinity and our range was negative infinity to infinity. So now our domain, and this is true for all exponentials, is negative infinity to infinity. And the range is the domain of the original function. So 0 to infinity. And then I believe I'm going to have to scroll down. There's one more question. Yeah, what's the graph of that look like? So let me erase some of this. And yeah, so we're looking for, let's see if I can move that. No, not easily. We're looking for what looks like an exponential function. Well, when you have e to the x plus 6 equals y, I'm going to erase all the other stuff that's in the way of the graphs. Got my domain and range there so we can see that. This is going to be shifted left 6. It's inside the parent function because it's inside that exponent. And remember, you see opposite of what you see. So if it's a plus, it's to the left. If it's a minus, it's to the right. So normally just e to the x has a horizontal asymptote at y equals 0, crosses at the point 0, 1, because if you plug in 0, you get e to the 0 is 1. And it looks like this, just like a regular exponential function. Ours needs to be shifted to the left 6. So it can't be this one because it's shifted down 6. Can't be this one because it's shifted up. This one's shifted to the right, which is not what we wanted. This one is shifted to the left. And you can zoom in on those a little bit more, but usually visually you can tell which one is the correct one if you just know your transformations. All right, the next question I wanted to look at is number 21. Again, just slightly different than previous versions of the exam. We had 1 or 2 of these on the practice test of the set of 4 videos that I'd made previously. But this one's a little easier actually. So if you're trying to solve an exponential function and you can get same base, then you do not need to go to logarithm form. You can, but it's just too much work. So if I can write these as the same base, I can set the powers equal. So 25 is 5 squared, which is the same base as the other side. So since our bases match, we set the exponents equal and we solve. So the solution set to this one is 7. And then the last one that I needed to do to go with the previous videos is number 22. So this one is transformations of functions again, but it's an exponential. So again, we kind of already did a little bit of this. And like I said, in the previous video that I made in a former semester, the big deal with these was that they were all matching and it was really hard to answer those questions. But we want to look at this as we've got the parent function y equals 4 to the x. And we've got this function, which has now been shifted to the right 2, because again, that shift is happening inside the parent function of 4 to the x. It's not happening at the end as like a 4 to the x and then a space and then a -2. So this is going to be right 2. Domain, let's go ahead and get that out of the way. Exponential functions are always negative infinity to infinity. The range has to do with if we shift it up or down, because usually it's 0 to infinity as long as we have not shifted up or down. We did not shift up or down, so this will still be 0 to infinity. So if we had shifted down 2, we would be at -2 to infinity. If we shifted up 3, we'd be at +3 to infinity. And again, none of these are brackets because you can't have a bracket on an infinity, and parentheses on a 0 means we can't touch or cross that line. We don't actually touch the value of 0. The horizontal asymptote is going to be y equals 0 for this one. Let me see if there's any other questions before we do the graph. Yeah, so there's one horizontal asymptote at y equals 0 and the y-intercept. Okay, so let's go ahead and get that. So the y-intercept would be f of 0 equals 4, 0 minus 2. That's going to be 4 to the -2. Remember, that means you flip it. So it's 1 over 4 squared, or 1/16. And on this one, I believe they just have you write the number. I know it's weird. Please be aware, I look at all of that when I do your final exam partial credit, when you submit your scratch work. If you have the right value, but you didn't follow the directions, I do give you most of the points back. I still take a tiny bit off for not following directions, but they just want the integer. So they just want the 1/16. They don't want the ordered pair. So to graph this, we're supposed to click on our graphing tool. And this one is one you have to be very specific with. So you're picking, we're not doing a logarithm. This is logarithm. This is quadratic. This is cubic. This is exponential. And we are trying to, let me clear all my drawings. We're trying to graph 4 to the x minus 2. So we're going to plot that point. We can't actually plot easily 0, negative, or 1/16, not put negative. So I'm going to need more points. So the first one you usually want to get is what makes the exponent equal to 0. So if I plug in a 2 into my function, the reason I'm picking 2 is 2 minus 2 equals 0. You always want that point to be the first one you graph on your exponential, the one where you get a 0 for the exponent. So that's going to be the point 2, 1. Then I usually pick a point just to the right of that because it won't be a fraction. So we're going to plug in 3. So that'll be 4 to the 3 minus 2, which is 4 to the 1, which is 4. So my second point will be 3, 4. So my first point, go back to graphing, is going to be 2, 1. Oh, and see, this is why I thought, yeah, these are weird. So you start getting your points, but then you have to do the transformations. We do not have any reflection over the x-axis or y-axis, so we don't need to check that. We do have a base of 4. Always triple check that that's right. We don't have a vertical stretch or compression or a horizontal stretch or compression, but we do have some shifting. So we didn't have a vertical shift. We had a horizontal shift to the right 2. So right 2, and we can check this. It's good to have the points. 2, 1 and 3, 4. So this graph does match with what I expected. And that is it. So hopefully with the previous 4 videos that I'd made, plus this set of examples with some graphing help, that will be enough to help you prep for your final exam.